Hi everyone, welcome to our channel. From this tutorial, we are going to learn Engineering Mathematics 1. In Engineering Mathematics, first we will see sequence and series. Let us know what is sequence. Sequence, it is the collection of objects in a particular order and it contains elements or terms. In sequence, the repetition of elements is allowed and it is denoted by flower brackets. The main difference between set and sequences are: in sequence, the order of elements should be allowed, whereas in set, the order of elements is not allowed. In sequence, the repetition of elements are allowed, whereas in set, the repetition of elements is not allowed. General term or nth term of a sequence is denoted by an. N is the subscript. Many of students having a doubt how to find nth term of a sequence. The general term or nth term of a sequence is the pattern of the elements in a sequence. Let's take example 1. Let us take example 1, the sequence of all even numbers 2, 4, 6, 8 and so on. 2 is the first element, 4 is the second element, 6 is the third element. These are all the multiples of 2. Therefore, nth term of this sequence is 2n. Let's take example 2, the sequence 3, 5, 7, 9, 11 and so on. The first term is 3, second term is 5, third term is 7, fourth term is 9 and so on. 3 equal to 2 into 1 plus 1, 5 equal to 2 into 2 plus 1, 7 equal to 2 into 3 plus 1 and so on. These elements follow a pattern. The pattern is 2n plus 1. This is the nth term of this sequence. Next one is finite sequence and infinite sequence. Finite sequence, the number of elements in the sequence is counted. For example, sequence 1, 2, 3, 4, 5. These are all 5 elements in the sequence. We can count these elements. Infinite sequence, the number of elements in the sequence cannot be counted. For example, sequence of natural numbers 1, 2, 3, 4, 5 and so on. We cannot count it. Okay. Next one is monotonic sequence. Here we have two types. First one is monotonically increasing. In this sequence, each term is greater than or equal to 1 before it. Okay, for example, sequence of even numbers 2, 4, 6, 8 and so on. First term is 2 and second term is 4. 4 is greater than 2 and third term is 6. 6 greater than second term 4. Okay, this general form is an plus 1 greater than or equal to am. Next one is monotonically decreasing. In this sequence, each consecutive term is less than or equal to previous one. For example, sequence 20, 10, 0. In this sequence, first term is 20, second term is 10, third term is 0. Second term 10 is less than the first term. And third term 0 is less than the 10 second term. Okay, this is monotonically decreasing. General form is an plus 1 less than or equal to an. Next one is bounded sequence. If the sequence of real numbers is such that all terms are less than the some real number capital M, then the sequence is said to be bounded from above. An is less than capital M. Less than the capital M. An is less than the capital M. Here capital M is the upper bound. If the sequence of real numbers is such that all terms are greater than the some real number small m, then the sequence is said to be bounded from the below. An is greater than the small m. Here small m is the lower bound. If the sequence as both bounded from above and bounded from below, then the sequence is said to be bounded. For example, sequence 1, 2, 3, 4, 5 and 6. Here the sequence is less than 7. An is the less than the 7. 7 is the upper bound and An is greater than 0. 0 is the lower bound. This sequence has both bounded from above and bounded from below. Then this sequence is said to be bounded. Next one is limit. If the sequence converges to some particular value L, is known as limit of a sequence. It is denoted as limit as n tends to infinity An equal to L. Next one is convergent. If the sequence converges to some limit, it is convergent. Limit n tends to infinity An equal to finite value. Okay. For example, sequence 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 and so on. The nth term of this sequence is 1 by n. Applying limit to the nth term, limit as n tends to infinity 1 by n equal to 1 by infinity equal 0. It is converges to 0. The sequence converges to 0. Therefore, the sequence is convergent. Next one is divergent. If limit n tends to infinity An equal to infinity plus or minus infinity, then that sequence is divergent. For example, nth term of sequence is n. Applying limit to the nth term, limit as n tends to infinity n equal to infinity. This sequence is divergent. Next one is oscillatory. If the limit of a sequence is not unique, oscillates finitely or oscillates infinitely. For example, nth term of a sequence minus 1 whole power n. Applying limit to the nth term of a sequence, limit n tends to infinity minus 1 whole power n equal to 1 if n is even, minus 1 if n is odd. Therefore, the sequence is oscillatory. Okay, let's see some problems. Determine the nature of the following sequence whose nth term an is. Here we have nth term of sequence an equal to n square minus n by 2n square plus n. Applying limit to the nth term an equal to limit n tends to infinity n square minus n by 2n square plus n. Limit n tends to infinity, common n square from numerator and denominator, 1 minus 1 by n, n square into 2 plus 1 by n, cancelling n square and applying limit to 1 minus 1 by n by 2 plus 1 by n, 1 minus 1 by infinity by 2 plus 1 by infinity. 1 by infinity is 0 and 1 by infinity 0, 1 by 2. Okay, here the sequence is converges to 1 by 2, so it is convergent. Next example is an equal to tan hn. Here we have given nth term of sequence an equal to tan hn. We want to find nature of this sequence. Applying limit to this nth term of sequence, limit n tends to infinity an equal to limit n tends to infinity tan hn. First, convert the tan h into simple form. Tan h equal to sin h tan hn cos hn. Tan hn equal to sin hn by cos hn. Since sin hn equal to e power minus a e power plus a e power minus a by 2, cos ha e power a plus e power minus a by 2, okay. sin hn equal to e power n minus e power minus n by e power n plus e power minus n. Here 2 is cancelled. E power n minus 1 by e power n. E power n plus 1 by e power n. E power 2n minus 1 by e power 2n plus 1. E power n power n. E power n is cancelled. Okay. E power 2n minus 1 by e power 2n plus 1. E power 2n is common. 1 minus e power 2n. E power 2n 1 plus 1 by e power 2n. E power 2n, e power 2n is cancelled. Then apply the limit. Limit n tends to infinity 1 minus e power 2n by 1 plus 1 by e power 2n equal to 1 minus 1 by infinity by 1 plus 1 by infinity equal to 1 by equal 1. Therefore it is convergent. Next one is example 3. Here we have given the nth term an equal to 2 plus minus 1 whole power n. Applying limit to the nth term, limit n tends to infinity an equal to limit n tends to infinity 2 plus minus 1 whole power n. Limit n tends to infinity 2 plus limit n tends to infinity minus 1 whole power n. Divide the limit. Okay, 2 plus limit n tends to infinity 2 equal to 2 plus minus 1 if n is odd plus 1 if n is even. Therefore given sequence is oscillatory. Here we have nth term of a sequence an equal to 3 plus 1 by n. Applying limit to this nth term, limit n tends to infinity an equal to limit n tends to infinity 3 plus 1 by n. Applying limit to both terms 3 and 1 by n. Limit n tends to infinity 3 plus limit n tends to infinity 1 by n. Limit n tends to infinity 3 equal to 3 because this is constant plus limit n tends to infinity 1 by n 1 by infinity 3 plus 0 equal to 3. Therefore given sequence is convergent. Next example is here we have nth term of sequence an equal to e power n. Applying limit to this nth term, limit n tends to into an equal to limit n tends to infinity e power n for e power infinity equal to infinity. Therefore given sequence is divergent. The next example is determine the nth term and nature of a sequence. Given sequence equal to 3, 9, 19, 33 and so on. Solution. Here first term is 3, second term is 9, third term is 19 and fourth term is 33 and so on. Okay. First 2 into 1 square plus 1. Next term is 9. 2 into 2 square plus 1. Next term is 19. 2 into 3 square plus 1. Next term is 2 into 4 square plus 1 and so on. Therefore nth term of the sequence an equal to 2n square plus 1. Okay, for example, you want to find ninth term, substitute the 9 in the place of n in the nth term, 2n square plus 1. Okay, let's see. Term a9 equal to 2 9 square plus 1. 9 square is 81 plus 1, 162 plus 1, 163. Ninth term is 163. Okay, next we want to find the nature of this sequence. Applying limit to the nth term, apply limit n tends to infinity an, limit n tends to infinity to n square plus 1. Okay, apply limit 2 into infinity square plus 1, therefore infinity. Therefore given sequence is divergent. Okay, that's it for this tutorial. If you want more information, please subscribe our channel.